Picture this. You're a Luftwaffe test pilot in June 1944, strapped into the cockpit of a brand new TA-154 Moskito. The engines roar to life, the wooden airframe vibrates beneath you, and you begin your takeoff roll. This is Germany's answer to the British Mosquito. Sleek, fast, deadly. You're here to push it to its limits, to see what this wooden wonder can really do. You climb through 3,000 meters, then 4,000. The aircraft handles beautifully. You level off and begin your high-speed run, watching the airspeed indicator climb 500 kilometers per hour, 550, 600. Everything feels solid. This is what Germany needs, a night fighter that can actually catch those RAF bombers tearing through the Reich's skies every night. Then you hear it, a sound that doesn't belong, a crack. Not loud, not dramatic, just a single sharp crack from somewhere in the wing root. You glance out at the port wing, and for a moment, everything seems fine. But then you see it, a thin black line appearing along the upper surface, spreading like a fracture in ice. The wing is coming apart. You have maybe 3 seconds to process what's happening before the entire wing section tears away from the fuselage, the aircraft rolls violently, the controls go dead in your hands. You're not flying anymore, you're falling, tumbling through the sky in what's left of Germany's great hope for a wooden night fighter. And as you scramble for the bailout procedure, one thought races through your mind. This aircraft was brand new. It had just been assembled. How could this possibly happen? When it comes to wooden aircraft of the Second World War, one name soars above all others, the de Havilland Mosquito. Built primarily from plywood and balsa, this British marvel could outrun most fighters, strike with precision, and return home when others couldn't. It was fast, versatile, and most infuriatingly for the Germans, it worked brilliantly. By 1942, the Mosquito was becoming a serious problem for the Luftwaffe. It could photograph German defenses with impunity, bomb Berlin in broad daylight, and slip away before interceptors even got off the ground. Meanwhile, Germany's own night bomber force was struggling, and Allied bombing raids were intensifying. General Field Marshal Erhard Milch saw an opportunity. Germany still had plenty of Junkers Jumo engines sitting in warehouses, and building in wood would save precious aluminum for other projects. The challenge fell to Focke-Wulf and Professor Kurt Tank, one of Germany's most respected aircraft designers. His team, led by structural engineer Ludwig Mittelhuber, proposed Design 1, a twin-engine, high-speed aircraft built using mixed materials, 50% wood, 39% steel, with the remainder fabric and various composites originally conceived as a fast bomber. It would soon be redirected towards something Germany desperately needed, a purpose-built night fighter. By October 1942, the project had a new designation, TA-154. It would carry 4 30mm cannons in the nose, devastating firepower. Along with cutting-edge radar to hunt British bombers in the darkness. On paper, it looked like a winner. Wind tunnel tests were promising. The design seemed sound. Optimism was high. The pressure was immense. Hermann Göring himself had become obsessed with the Mosquito problem. At a conference in March 1943, his frustration boiled over. "It makes me furious when I see the Mosquito. I turn green and yellow with envy. The British, who can afford aluminium better than we can, knock together a beautiful wooden aircraft that every piano factory over there is building, and they give it a speed which they have now increased yet again. Germany needed its own wooden wonder, but building a high-performance aircraft from wood isn't like building furniture. The loads, the stresses, the aerodynamic forces, everything had to be precisely calculated, and more importantly, precisely bonded wood laminations had to be flawless. Joints had to hold under extreme conditions. And that meant one thing above all else mattered. The adhesive for the TA-154, Focke-Wulf engineers specified a synthetic resin adhesive called Tego film, produced exclusively by the Goldschmidt Company in Essen. This wasn't ordinary glue. Tego film was a phenolic resin film adhesive that came in dry sheets, was applied between wood layers, and then cured under heat and pressure. The process created bonds that were exceptionally strong, chemically stable, and crucially, free from moisture that could cause warping or degradation over time. The British understood this principle intimately. De Havilland's success with the Mosquito wasn't just about clever design. It was about obsessive attention to adhesive quality and bonding procedures. Every joint was inspected, every cure cycle monitored. The glue was as much a part of the aircraft's performance as the engines or the airframe itself. German engineers knew they needed the same level of quality. Tego film had been tested, proven, and specified throughout the Ta 154's design documentation. The wings, built as a single solid two-spar structure, relied entirely on these bonded joints to handle the massive loads generated during flight. There was no backup, no mechanical fasteners, just wood and adhesive, working in perfect harmony. On July 1, 1943, the first prototype took to the skies. Test pilot Hans Sander, with Kurt Tank riding along in the observer's seat, reported excellent performance. When the TA-154 was flown in competition trials against the Heinkel He-219 and Junkers Ju-388, it outperformed both rivals, reaching an impressive 700 kilometers per hour. The handling was nimble, responsive. Germany, it seemed, had its Moskito killer. There were problems, certainly. The landing gear proved fragile. Multiple prototypes suffered collapses on landing. When radar and full armament were installed, the added weight and drag dropped performance by about 75 kilometers per hour. The wooden fuselage couldn't handle the recoil from the heavy cannons, literally shaking itself apart during firing tests. After one fatal crash, engineers determined the wooden cockpit structure was too weak and ordered it replaced with metal. But these were solvable problems. Engineering challenges, not fundamental flaws. Adjustments could be made, reinforcements added. Despite the setbacks, production planning moved forward. The goal was ambitious. 250 to all 154 assessed per month by November 1943, rising to 500 or more by mid-1945. The aircraft would replace older night fighters and help turn the tide against the Allied bombing campaign. What nobody fully appreciated yet was that the entire program was built on a single point of failure: one factory, one company, one adhesive. And on May 29, 1943, that point of failure was about to be eliminated. The Allied bombing campaign against German industry was systematic, and ruthless intelligence analysts studied German production networks, identified critical bottlenecks, and prioritized targets accordingly. The Goldschmidt chemical factory in Essen wasn't making tanks or bombs or fighter planes. It was making adhesive. But Allied intelligence understood something crucial. Modern warfare isn't just won with weapons. It's won by destroying the industrial capacity to build those weapons. On the night of May 29, 1943, Allied bombers struck the Goldschmidt facility. The factory was destroyed. Production of Tego film adhesive ceased immediately. At first, this seemed like a manageable setback. Germany had other chemical companies. Dynamit AG and others could surely produce a replacement adhesive. After all, it was just glue, wasn't it? The chemical composition was known. The process could be replicated, except it couldn't, at least not quickly. And not with the same quality. Tego film wasn't just about chemistry. It was about manufacturing process, quality control, and years of refinement. The replacement adhesives supplied to Focke-Wulf came from companies with no experience in aeronautical adhesives. They hadn't spent years perfecting the formulation, the curing process, the quality standards, and critically, they were working under wartime pressure to deliver something, anything that could keep production moving. The replacement glues had problems. They cured unevenly, creating internal stresses in the wood laminations. They introduced moisture during the curing process, which caused warping and swelling. Worst of all, some formulations were slightly acidic, and acidic adhesives, in contact with wood over time, do something insidious. They begin to break down the very material they're supposed to be bonding. Nobody at Focke-Wulf knew this yet. The first production aircraft rolled out in June 1944, assembled with the new adhesive. Expectations were cautiously optimistic. The aircraft looked fine. Ground tests seemed normal. Then came the flight tests. The first production TA-154 suffered catastrophic wing failure during a high-speed run. The pilot barely had time to understand what was happening before the aircraft disintegrated. A second aircraft followed shortly after, with the same horrifying result. Then a third. Wings were separating from fuselages. Structural bonds were failing. Aircraft were literally coming apart in the air. An emergency investigation was launched. Kurt Tank, the designer whose name was on the aircraft, found himself under intense scrutiny. Some even accused him of sabotage, a charge that, in Nazi Germany in 1944, could mean a death sentence. But the investigation eventually cleared him. The problem wasn't Tank's design. It wasn't poor workmanship. It wasn't pilot error. It was the glue. Meanwhile, across the English Channel, RAF Mosquito crews were demonstrating what a properly built wooden aircraft could achieve. In raids over Germany, they operated with devastating effectiveness. One pilot noted simply that the Moskito sat on the ground looking pert and eager, ready to strike deep into enemy territory with near impunity. On March 17, 1944, as the Ta 154's problems mounted, Oberst Diesing, head of planning at the German Air Ministry, delivered a crushing assessment to Kurt Tank. The aircraft, he said, was unsuitable for normal pilots. The handling was poor, the control forces excessive, and alarmingly, pieces of the aircraft fuselage fell off when firing the guns. This was the bitter irony. While Germany struggled to build its wooden night fighter, the very aircraft that inspired it, the Moskito, continued to prove that wooden construction could work brilliantly. The difference wasn't the concept, it was the execution, and in particular, it was the adhesive. By summer 1944, the TA-154 program was in crisis. Production had slowed to a crawl. Each new aircraft was suspect. Test pilots approached their flights with understandable nervousness. Nobody wanted to be at 6,000 meters. When their wings decided to separate, ground crews began finding disturbing evidence during inspections. Delamination in wing structures, moisture damage in critical joints, corrosion appearing where the acidic adhesive had been eating away at the wood for months. The irony was almost poetic. The TA-154 had been conceived as a way to save strategic materials. Aluminum could go to other projects while Germany's abundant timber resources and skilled woodworkers built night fighters. But by 1943, Germany didn't actually have abundant skilled woodworkers anymore. Most had been conscripted into the military or absorbed into other war industries. The specialized techniques required for aeronautical woodworking, precise lamination, controlled bonding under exact temperature and pressure, couldn't be taught quickly. And even if they had the workers, and even if they had the skills, it didn't matter. Because without the right adhesive, the entire concept collapsed, literally. Focke-Wulf attempted fixes. They tried reinforcing critical joints with metal brackets. They experimented with different curing procedures for the replacement adhesives. They instituted more rigorous inspection protocols. But these were bandages on a hemorrhage. The fundamental problem that they didn't have access to a proven, reliable adhesive suitable for high-stress aeronautical applications remained unsolved. Meanwhile, the war situation was deteriorating rapidly. Allied bombing raids were intensifying. The Normandy landings in June 1944 opened a new front. Resources were stretched impossibly thin. Every kilogram of aluminum, every liter of fuel, every skilled worker had to be prioritized. And the Ta 154, which was supposed to ease these pressures, had instead become another drain on Germany's dwindling resources. The few TA-154s that did reach operational units, perhaps 7 to 12 aircraft in total, were assigned to Night Fighter Wing 3, operating in northern Germany and the Baltic. But there's no solid evidence they ever flew combat missions. They may have been used for familiarization flights, for evaluation, for testing, but the intercepting RAF bombers at night, the very purpose for which they were designed, that job continued to fall to the reliable, if aging, BF-100s and Ju-88s. Some of the surviving airframes were earmarked for desperate last-ditch schemes. One proposal called for converting them into missile composite aircraft, where the TA-154 would be packed with explosives, mounted beneath an FW-190 fighter, and flown by the fighter pilot toward a target before being released as a massive guided bomb. Another, even more extreme concept, the Pulsar-Störer, envisioned packing the aircraft with explosives and having a pilot guided into bomber formations before bailing out, leaving the unmanned aircraft to explode among the enemy. These weren't the plans of a confident military machine. These were the desperate improvisations of a losing side grasping for any advantage, no matter how wild. And tellingly, neither concept seems to have progressed beyond initial conversions. The TA-154's fragile landing gear would have collapsed under the weight of the missile configuration anyway. Launch from a trolley was proposed, but the entire scheme was eventually abandoned. The end came in August 1944. Erhard Milch, the same field marshal who had championed the project from the beginning, officially terminated it on August 2nd. His order was blunt and absolute. No more work on unfinished airframes, no more testing. And critically, it is forbidden to use even one more drop of gasoline for the Ta-154. In the context of late-war Nazi Germany, where accusations of sabotage or defeatism could be fatal, this wasn't just bureaucratic language, it was the death warrant for the entire program. In total, somewhere between 30 and 50 Ta-154s were completed, depending on how you count prototypes and heavily modified airframes that received new registry numbers. Most never flew operationally. Many were destroyed on the ground by Allied bombing raids, a final irony for an aircraft designed to stop those very raids. Others were lost in crashes or landing accidents, their fragile landing gear collapsing or their structural bonds failing at the worst possible moments. By spring 1945, as Allied forces closed in, the few surviving TA-154s at Night Fighter Wing 3 were unceremoniously pushed off the runway when fuel ran out. They were later destroyed to prevent capture. Only one intact Ta-154 survived the war at Langenhagen, where it was briefly evaluated by Allied intelligence officers who were likely unsurprised by what they found. Today, not a single complete TA-154 exists. There's a replica of the front fuselage section on display in Germany, a museum piece representing what might have been, but the aircraft itself. Germany's answer to the Mosquito, the wooden wonder that was supposed to turn the tide of the night war, vanished into history as thoroughly as its structural bonds vanished under stress. The story of the TA-154 isn't really about aircraft design. Kurt Tank was a brilliant engineer. The basic concept was sound. Wooden construction could work, as the Mosquito proved every single night over Germany. The problem wasn't vision or ambition or even resources in the traditional sense. The problem was a single factory producing a specialized adhesive that nobody fully appreciated until it was gone. Modern military strategists have a term for this: a single point of failure. In complex systems, whether weapons programs, supply chains, or entire war efforts, there are often hidden dependencies that seem minor until they're disrupted. The Goldschmidt factory wasn't producing tanks or ammunition. It wasn't building fighters or bombers. It was making glue, and yet its destruction effectively ended an entire aircraft program. Allied intelligence understood this principle better than perhaps even they realized at the time. They weren't just targeting obvious military production, gun factories, tank plants, aircraft assembly lines. They were studying the entire industrial ecosystem, identifying the small specialized facilities that the bigger programs depended on. A bearing factory here, a specialized alloy plant there, and yes, a chemical facility producing aeronautical adhesives. The Germans learned this lesson too, though far too late for the TA-154. When they developed the Heinkel HE-162 Volksjäger, another late-war wooden aircraft, they paid obsessive attention to adhesive selection and quality control. By then, they'd figured out what the British had known all along. You can't build a high-performance wooden aircraft without a high-performance adhesive to hold it together. But here's the deeper lesson, one that extends far beyond World War II or wooden aircraft. Modern warfare, modern industry, modern society itself operates on vastly complex supply chains and manufacturing networks. We depend on specialized components from specialized suppliers, often without fully mapping those dependencies until something breaks. A semiconductor fab in Taiwan, a rare earth refinery in China, a specific chemical process known to only one company, these are today's equivalents of the Goldschmidt factory. The TA-154 test pilot who watched his wings separate at altitude wasn't experiencing a design flaw. He was experiencing a supply chain failure that manifested 30,000 feet above Germany at 600 kilometers per hour in the most catastrophic way possible. And that, perhaps more than anything else, is why the story of the TA-154 Mosquito matters. It's a reminder that wars aren't won just by soldiers or weapons or tactics. They're won by logistics, by industrial capacity, by supply chains, and by understanding which seemingly minor components are actually critical vulnerabilities. The TA-154 didn't fail because it was a bad aircraft. It failed because someone in Allied intelligence looked at a factory making glue and understood that sometimes the smallest target yields the biggest impact. One factory, one adhesive, one bombing raid, and Germany's wooden wonder never stood a chance.